So we have a triangle. It's not a right angle triangle, so we're not allowed to use SOHCAHTOA. You're also not allowed to use a squared plus b squared equals c squared. Both SOHCAHTOA and a squared plus b squared equals c squared are only true if you have a right angle triangle. So here we don't have a right angle triangle. We want to solve for angle n. So that's this angle right there. And in order to solve something with the sine law, you need to have pairs of things. So we need to have an angle and its opposite side. Can you see that? I'll circle it in purple. That you have that here. Those two are connected. In order to find something else, you need another pair that are connected. Can you see that currently with angle n would be connected with this side, but unfortunately, we don't know that side. So we have a little bit of a problem because we don't know the side opposite with n. So we will not be able to, in this question, solve for n directly. But with the sine law, there's probably something that we could solve. Do we have another angle or another sine that could pair together? And the answer is yes. We could solve for p because we know the opposite of p. So with that in mind, we go to our sine formula, and our sine formula always says, and I always put whatever I'm solving for, I can solve for p. I'll put that on top of my fraction. So underneath here, which side goes with p would be 10. Equals, then I'll go to the purple ones, and I'd write sine of 92 degrees over 11.8. At this point, it is not hard to get sine of p by itself. You would have to multiply by 10 and multiply by 10. These 10s would simplify. And we would get sine of p by itself. If I type that into my calculator, I get 0.8469. And now this is where we have to make some thoughts about what's happening with solving this. Why is this a little bit interesting? Well, this is what you just did your assignment on. Obviously, this isn't one of the values that's on a special triangle. You would have to use your reference angle and your cast rule. Can you see that if I have sine of p equal to 0.846, according to the cast rule, it could be in quadrants 1 and 2. It's definitely not in quadrant 3 and 4. If I draw a picture of those two angles, I could have a triangle in quadrant 1. I could have a triangle or an angle in quadrant 2. This would be my reference angle. And this would be my actual angle. So in grade 9 and grade 10, trigonometry would only deal with quadrant 1 answers. In grade 11, we have all the quadrants to think about, but some of them are going to make sense and some of them are not going to make sense, and we'll see that in a second. First of all, if we label this triangle, can you see that you know sine is opposite over hypotenuse? How could I write this as a fraction? I could put it over 1. So technically I have on the opposite side 0.8469, and my hypotenuse is 1. If I wanted to find my reference angle, sine of my reference angle is 0.8469. So my reference angle, if I go to my calculator, is 57.88. So my actual angle could either be 57.88, or in quadrant 2, it could be 180 minus that, 122.12. Now we are dealing with an actual triangle in this question. Let's go back to our picture. We were solving for angle P. We just said, and it says to the nearest degree, so I'm going to round those to 58 and 122. It means that angle P is either 58 or 122. Do both answers make sense? Which one doesn't make sense? And how come you're saying 122 doesn't make sense to you? Yeah, angles in a triangle always add up to 180 degrees. That is always true. So if you used 122, can you see that the angles will add up to more than 180? And when that happens, that means it's not possible. So the only answer that's possible here is the 58. But we are going to get some triangles where both answers are possible. So since 58 is the only one that's possible, you could now label this angle as 58. What did question want us to solve for at the beginning? Angle N. We now know two of the angles in there, 58 and 92. We could say, well, what adds up to make 180? We can now say that angle N will equal 180 minus 92 minus 58. And angle N is equal to 30 degrees. What's coming up? Okay, what we just saw in this question. Okay, what we just saw in this question was connected to the triangles that we did here at the beginning. Just erase this for a second. Do you remember yesterday when we drew the triangles that if it was 7 centimeters, only one triangle was possible? But if we had 3 centimeters, that 2 triangles were possible. The key here is noticing that when we drew the 7, did it make sense that there was only one triangle because the 7 is bigger than the 5? Anytime that opposite side is bigger, there's only one triangle that can be drawn. In the example that we just did is connected to that. I'll go back to that example. Oops. There it is. I'll go back to the example. Can you see with the angles, I'm going to erase all of this extra stuff here, that the angle that we know is the 92. can you see that the side opposite that 92, the 11.8, is bigger than the adjacent side of 10? And that is connected to what we drew originally, where that opposite side was 7. Here, the side opposite the angle, if it's bigger, then only one triangle will be possible. But we're going to find out in example 2, if I gave you this and said, solve for it, not drawn to scale, obviously, and I tell you that side is 3 centimeters. Look what happens here. We could set it up the same way. Can you see that you would solve for this angle because it's opposite this one, and you know the 3 is opposite the third. So I could set my sine law, and I could say that sine of, I don't know, I'll label these, sine of c over 5 is equal to sine of 30 over 3. Multiply both sides by 5. This could be a math question. What's sine of 30? 1/2. So 5 times 1/2 divided by 3 is 5/6. You could then find that, oh, it's positive. So according to my CAS rule, sine is positive in quadrant 1 and 2. So I have a possibility of an angle in quadrant 1, a possibility of an angle in quadrant 2. I can label my reference angle for both of those and label my actual angle. And if I do sine inverse of 5/6, so my reference angle for C, this should be C. My reference angle for C, sine inverse of 5/6 is 56.4. That means that angle C is either 56.4 or, to find this one in quadrant 2, I'd have to do 180 minus 56.4. 123.6. And I want you to notice, if this is 56.4 or 123.6, do you see that they both still work? In fact, the 56.4 one, I'll draw it on here, would match up with that triangle. And the 123.6 one would match up with that triangle. And so we have 2 possible answers in that situation. So our cast rule and our sine law become important to work together. Sometimes we're only going to get one possible solution. Sometimes we're going to get 2. You can easily tell that there's only one if the side opposite the angle is bigger than the side adjacent to the angle. That was our first example. But when the side opposite the angle is less, it opens up a lot of possibilities. Sometimes there will be 2 answers, like we saw with the 3 here. Sometimes, remember the last one where we made only 1 centimeter long? Sometimes you're going to try to solve it and you'll find out there's no answers possible. You're going to get an error on your calculator because it's going to be frustrated. It's going to say that doesn't work. Okay, questions for practice. For example 2 is question number 4. So circle number 4.